We are recording now. So for those of you that have been here before, I'm Maxine, and we're going to be going through a set of homework questions for review for chapters 4 and 5. If you need to email me, my email address is here, but you can also just email me at maxine.horn. I go by my middle name. Sorry, that's confusing, I know. All right. So, real quick, I just want to say that for this chapter, I mean, it's always a good test strategy, but what I did is I kind of made like a study sheet, a set of just notes that are kind of maybe some like important like vocabulary and like how to do things by hand versus how to do it on the calculator. And I just kind of, wrote it on some notebook paper, nothing fancy, but just this is the kind of thing that you want to be trying to do as you're going through the chapters is, you're making notes as you're learning it, but then also having like one sort of unified place where maybe you've got all your formulas or, you've got all of your steps for how to use the calculator. I will be, I scanned this in, so I'm going to email you a PDF copy of this so that, you can take a look at it and see if it, maybe it matches up with some of the notes that you have, or, maybe it'll remind you, oh, that's right, I should write that down because, that's something I have to refer back to a lot. Your study sheet will probably look different from mine. You can also feel free to go back and change your study sheet, because maybe when you go through the chapter, maybe you write something down, or maybe you don't write something down that doesn't feel important, but then as you start to do problems, maybe you realize, oh, that was important, I need to go back and add that in. So like here, I actually did like an example problem, as part of the that particular section. But yeah, so just, another test taking strategy, another study strategy is to make yourself a study sheet. And it doesn't have to be as involved as this one. Again, if maybe the only thing that you have trouble with is remembering, where do I go in the calculator for things, or, what's the formula for specific things, or what's the symbol for different things. That can be the type of thing that you put on your sheet. So, all right. So like I said, I will email you a copy of that, and we might refer to it kind of as we're working through things here today. Okay, so let's jump in. So state whether the variable is discrete or continuous, the cost of a statistics book. So real quick, let's remind ourselves sorry, I've got my cords all stuck here. The definitions here. So if something is finite or countable, then that is something that you can say is discrete. So in this example, we're talking about the cost of something, okay? So when we're talking about money, dollars, it only goes to 2 decimal places, right? I can't get any more exact than that. Whereas if I have, and I'm actually going to kind of show both of these at the same time here. Let me do it the other way. This other one, the blood pressure of a group of students the day before their exam, that would be continuous because by definition, it can take any value. It can take on any value within a given range. So think like a range of things on a number line. So for here, I can't have a half of a cent or 0.3 of a cent. it is finite, countable. So that's what makes it discrete. Can take on any given value within a given range. And it's limited only by the precision of the measuring instrument. So maybe you have a blood pressure monitor that is like a dial, right? Where it like goes like that. So it's just, a range of values there. But you might have an electronic one that displays like a particular number, how many ever decimals it can go on to or go out to. That is the limit. It's limited only by how precise that measuring instrument can be. Okay. All right, hopefully those make sense. I feel like they gave some good examples of kind of how to tell the difference with those. Okay, number 3, the random variable x represents the number of credit cards that adults have, along with the corresponding probabilities. Find the mean and the standard deviation. So when we want to find the mean, we're going to plug this into L1 and into L2. So you guys have done this before. You're going to go to Stat and then Edit. And then if you have things like I've got a bunch of things in here, if you need to clear it, you highlight up where it says L1, and then you hit Clear and Enter. Right, so highlight where it says L2, hit Clear and Enter, and then it clears the whole thing. Okay, so we're going to plug everything in here. So again, we're plugging things in under Stat. And then we went to just the number 1. Well, I mean, it's under the, oh, you guys can't see that, sorry. It's under the Edit, and we do number 1, Edit. And then you put them in L1 and L2, okay? So then we want it to calculate some things for us, right? So very, very similar to what we were doing in previous chapters. Just move this a little bit. So we're going to go Stat, and this time we're going to arrow over to Calc, right? So Stat, and then we go to Calc, and then we select number 1, which is 1 var stats, one variable statistics, and we have to tell it which lists to look at. So we have to make sure that we have L1 and L2 in there. And then quick reminder, your L1 is right here above your button 1. So if it's not already there, you're going to need to hit the second and then 1 so that it'll do what's in this sort of dark blue. You guys probably can't see that that's like a teal color. It's kind of like a shift button, right? So L1 and L2 and then calculate. Okay, great. So it gives us all these things, right? We've seen a display like this before. It's going to give us the mean, right? X bar is our mean, 1.23. So there's that. And then the standard deviation, which you might notice is that it doesn't even give us the sample standard deviation. It only gives us the population standard deviation. And you might notice that it's going to do that every time that you give it a probability here. Every time you give it a number that's less than 1. Because previously, when we were dealing with frequency distributions, we had Rx and then its corresponding frequency. But instead of frequency, we're doing probability here. So that's just something that you might notice is that whenever you're plugging in decimals here, it's only going to give you your population standard deviation. But it gives us that number, and there it is right there. Okay. All right. Number 4, use the probability distribution to complete parts A through E. Okay, so before we jump in, well, let's read through what it's actually giving us. The probability distribution of the number of overtime hours worked in 1 week per employee. I was getting ahead of myself. We don't need to pull the calculator menus out for this. So, all right, find the probability of randomly selecting an employee whose overtime is 1 or 2 hours. So what we are doing is we're finding the probability of 1 hour, and we're going to add that to the probability of 2 hours. Okay, so conveniently, they gave us all those probabilities, right? So keep in mind that they can display it like this, or they could have displayed it similarly to what we just had on the last one, right? 0, 1, 2, 3, 4, 5, 6. And then the corresponding probability. So I'm not going to actually write all of these out, but I just want you guys to see that they could have displayed it this way instead, right? It's the same thing, just can display it a different way. Okay, so the probability of 1 hour, well, the X is the number of overtime hours worked, so the probability of 1 is 0.058. And we're going to add that to, because they said 1 or 2 hours, we're going to add that to the probability of 2 hours. And that's all we're doing. We're just adding them up because it's 1 or 2 hours, right? So we add these up, we plug them into the calculator. And there we go. Sorry, you guys can't see that with the reflection. 0.185. Okay, so it's just a bunch of variations on that, right? Okay, find the probability of randomly selecting an employee whose overtime is 2 hours or less. Okay, so if we have 0, 1, 2, 3, 4, 5, 6, 2 hours or less. So 2 hours or less. So it can be 0 hours or 1 hour or 2 hours. We're going to take all 3 of those and add them together. Okay, so we're doing the probability of 0 hours plus the probability of 1 hour plus the probability of 2 hours, right? We're adding all of those up together. Now, conveniently, we just did add 1 and 2 together. So we can actually save ourselves a little bit of time here. This question kind of builds on that. We already found what 1 and 2 together add up to. So all we have to do is take what we found in the last one and add the probability of 0 hours to it. So that's what I'm going to do. So in my calculator, I've already added up the probability of 1 plus the probability of 2. To that, I'm going to add the probability of 0, 0.026. And that's how I get 0.211. Now, if you don't feel comfortable with that, if you find that you're kind of getting confused as to what you've added up previously and what you haven't, that's totally fine. You can absolutely just kind of start from scratch on this. And you can say, all right, probability of 0 plus probability of 1 plus probability of 2, right? So probability of 0 plus probability of 1 plus probability of 2. And you're going to get the same thing, okay? So for a lot of these types of problems, if you do feel comfortable kind of taking that shortcut, you can save yourself quite a bit of time if part of the question builds on the part before. Okay, find the probability of randomly selecting an employee whose overtime is from 3 to 6 hours inclusive. Okay, so we have 0, 1, 2, 3, 4, 5, 6. Okay, inclusive means we are including our barrier numbers. Whoops, sorry, didn't mean to overline hours there. So from 3 to 6, inclusive. So I can include 3 and I can include 6. Okay, so again, there's a couple of ways to do this. We could say, all right, I'm going to do the probability of 3 hours plus the probability of 4 hours plus the probability of 5 hours plus the probability of 6 hours. Or you might notice that we just found the probability of 0, 1, and 2, and that is the complement of what we're trying to find. right? So what I've circled is the complement of what is boxed in. So remember, the complement is the thing that you add to it to make it be equal to 0. Because with these distributions, all the probabilities together add up to 1, always. So if it's too much work to find this, I can instead find this and just subtract it from 1. And since we already found that, it's going to be a whole lot less work for us to just subtract this from 1. So we're going to do, instead of probability of this plus probability of that plus probability of that plus probability of that, we're going to do 1 minus the probability of that and that and that, which we already found. So 0 or 1 or 2, right? So 1 minus the probability of the complement of what we're being asked to find. So let's go ahead in our calculators. We're going to do 1 minus, and I want to subtract the thing that I found on the last problem. So again, making sure you guys know how to use your calculators. Way down here at the bottom, where it says ANS, answer, above the negative sign, I want the calculator to plug in the last number that I had there. So I'm going to go second answer. So 1 minus the last answer that I got, and I get 0.789. And then when you're going through and you're doing the homework, if you just want to kind of prove it to yourself, go for it. Just do it the long way and just make sure that you're getting the same answer, right? So let's say we wanted to prove that to ourselves. We could do the probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6, and we're getting the same answer. Okay. All right, find the probability of randomly selecting an employee whose overtime is from 1 to 3 hours inclusive. All right, so 1 to 3 hours, and we are including it. So 0, 1, 2, 3, 4, 5, 6. Okay, 0 to 3 inclusive. So again, if I want to save myself work, I can say, well, I already know 0, 1, and 2. So if I take what I got for 0, 1, and 2 and just add the probability of 3 to it, then that'll save me some work. Otherwise, I have to do this plus this plus this plus this. But I'm going to take a shortcut and I'm going to say, well, I already know this, so I'm just going to take it and add the probability of that to it. So what was just this part? Just these 3 added together, that was up here, right? That was the 0.211. So then we have this part is the 0.211, and then we also have to add the probability of 3 hours to that. Okay, so in my calculator, I'm going to go 0.211 because that's 0, 1, and 2, and then to that I'm going to add the probability of 3. Oops, did I plug something in wrong? 0, 1, and 2, 0.317. Oh, I'm so sorry. I'm so sorry. 1 to 3 hours. Oh, I'm trying to turn this into a problem and isn't. Okay, so 1 to 3 hours. And what did I box in? I boxed in 0 to 3 hours, right? I didn't box in what they wanted me to find. I'm just turning this into a completely different problem. Sorry about that. So let's try that again, shall we? 1 to 3 hours. 1 to 3. Okay, so have I done something previously that would make this a little bit easier? No, not really. So we can just do the probability of 1 hour plus the probability of 2 hours plus the probability of 3 hours. Okay. Probability of 1 plus the probability of 2 plus the probability of 3. Okay, and there we go. That's much better. Okay. And the last one for this, find the probability of randomly selecting an employee whose overtime is at most 4 hours. Okay. 0, 1, 2, 3, 4, 5, 6. Okay, at most 4 hours. So when we say at most 4, we're saying it can be everything up to and including 4. So you want to make sure that you're kind of familiar with the different ways that they can word these. Um, so at least, or at most, or, from this to this inclusive. Make sure that you've kind of got a handle on that. Okay, so there's several ways we can do this. So we've definitely found 0, 1, and 2 before. So we could take what we found there and add 3 and 4 to it. Okay, but you'll notice there's a bunch of numbers here, but there's only 2 numbers over here. So similar to what we did for this one, if I find this is the complement of this. So if I find this, I can subtract it from 1 and it will give me this because these 2 things are complements of each other. And that's going to be less work. It's going to be less steps than doing this. So I'm going to do 1 minus probability of 5 hours plus the probability of 6 hours. Right? 1 minus this will give me this. And that's going to be, I think, the fewest number of things that I need to plug into my calculator. So I can do that all at once here, right? I can do 1 minus and plug it in here, 0.18 plus 0.09. Okay. Or if you don't want to do that, you can do it kind of one step at a time. You can say, okay, 5 and 6. That's going to give me 0.27. 0.27 is the complement of what I want to find. So I'm going to do 1 minus. And you can either type in 0.27 or you can do that second answer. And either way, you're getting the 0.73, right? Excuse me. Okay. All right. Number 5, using the data given below, determine whether it would be unusual for a household to have no HD televisions. Okay, so they're giving us the number of televisions in a house, in a small town, and the corresponding probabilities. Okay, so they're giving us both the frequencies and the probabilities. So they said they're wanting us to determine whether it would be unusual for this many televisions. Sorry. Oh, okay, there you go. Now, hopefully now you can see that. Sorry about that. So no HD televisions. Well, no HD televisions would be 0, right? That's 0. So the corresponding probability is 3, 0.03. So remember that when you have to go from decimal to percentage, or I mean, you can, go back and forth. So 0.03, that's 3%, right? And then the rule is 5 or less, right? It's unusual if it's 5% or less. So this is 3%. 3% is less than 5%. So yeah, that's unusual because the probability of that is less than 5%. Okay, so this is one of those things that you've got to memorize, that it's considered unusual if it's 5% or less. Okay, all right. Number 6, the probability that a house in an urban area will be burglarized is 5%. If 20 houses are randomly selected, what is the mean of the number of houses burglarized? Okay, so when you're reading through these problems, if you're not quite sure where to start, what you want to do is you want to start labeling things, okay? They're spitting out numbers, they're spitting out percentages. Start labeling them. And what you're going to find is that you'll start recognizing the patterns of, okay, when I have these variables, I'm probably going to need to go use this formula or use this menu in the calculator, right? So, okay, they said that probability that a house will be burglarized is 5%. That's P, probability, 5%. Write it as a decimal. If 20 houses are randomly selected, well, that's an N, right? That's a sample size. That's a number of houses. What is the mean of the number of houses burglarized, right? What are they asking us for? They're asking us for the mean. And then hopefully at this point, you'll realize, oh, a mean, and they're giving us an N and a P. I know that formula. The mean is N times P. So again, this is something you've got to memorize, right? Now, if they had given you Q, so if they had said, real quick, remember that P and Q are complements of each other. They add together to be 1. So if they tell us that P, or you can do 1 minus P is going to give you Q, right? That's another way to represent that relationship. If they give you P, you can find Q by subtracting it from 1, right? So P would be the probability that a house in the urban area will be burglarized. Q would be the probability that the house in the urban area would not be burglarized. I don't see them doing that to you a lot where like they give you a P and ask for a Q or the other way around. But just be aware that your P value is not always like a positive thing. And I say positive in like as in a good thing, right? Because we're looking at P as somebody's getting burglarized. That's not a good thing. Anyway, so we're going to, now in this case, we don't need Q, but there will be other formulas where we do. I just wanted you to remember the relationship between P and Q. You can always find one if you have the other. All right, so we're going to plug in our numbers. Our N is 20, our P is 0.05. Right. And there we go, 1. So the mean of the number of houses burglarized is one house. Okay. Right, number 7. According to government data, probability that a woman between the ages of 25 and 29 was never married is 40%. Let's go ahead and write that down. In a random survey of 10 women in this age group, there's an N, what is the mean and standard deviation of the number that never married? Okay, so again, they're asking us for mean, standard deviation, and we say, oh, that's right, I know those formulas. Mean is N times P, right? Standard deviation, so again, this is one that you're going to have memorized. It's the square root of N times P times Q. Now, if you want, you can just go ahead and plug these in to find your mean, because we have everything we need in order to find the mean right now. Or you can find everything you need to find this as well, right? So we could label everything, find everything, and then go through and plug it in. I like to make sure I have all of my elements before I get started. So let's go ahead and find Q. So remember that Q is the complement of P. 1 minus P. So Q is going to be 0.6. Okay. So if P is the probability that a woman between those ages was never married, then Q is going to be the probability that a woman between those ages was married or had been married. Okay, so let's plug and chug, as they say. N is 10, P is 0.4. So that's going to be 4. And then for our standard deviation, we have an N of 10, a P of 0.4, and a Q of 0.6. So you can just plug that into the calculator, right? And just to make sure you guys know where your square root function is, it's right up here. It's above your square function. So again, to get that, you have to hit second and then that button. And then we're plugging in 10 times 0.4 times 0.6. Okay, and we want to make sure that we are rounding the way that they're rounding. They've gone to 2 decimal places. So again, quick reminder on rounding. I do this every time, but I just want to make sure nobody ever gets a problem wrong because they accidentally rounded incorrectly. So if I'm going to go to 2 decimal places, I look to the number to the right. If that number is 5 or more, then my underlined number goes up 1. If that number is not 5 or more, this number stays the same. This is 5 or more, so my underlined number goes up 1. It's about 1.55. And that's how we get our answer. Right, so again, our little study sheet thing here. Let's see, where did I do that? Yeah, so actually it's funny because on this page I forgot to include something and I went and included it afterwards. I meant to include this information directly under this, but I wrote this first and I wasn't going to erase it. But anyway, so yeah, knowing your the population parameters, right? Because we're talking about population values, not sample values of binomial distributions. Our mean is n times p. Our standard deviation is the square root of n times p times q. And they may ask you for the variance. I don't know that they will, but they might. So you'll need to know that that's the standard deviation squared, or just n times p times q. Okay. All right. Number 8. In a recent survey, hang on just one second, I'm going to get a drink real quick. Okay. In a recent survey, 63% of the community favored building a police substation in their neighborhood. If 14 citizens are chosen, find the probability. What are they asking us for? They're asking us for the probability that exactly 5 of them favor the building of the police substation, and then round the answer to the nearest thousandths. Okay, so again, let's start labeling things. So they gave us probability, or they gave us, yeah, I mean, the way that they've worded it may not sound like a probability, but they're saying, but we're calling that the probability. Because if 63% of the community favored it, then there's a 63% chance that somebody favored it. And then they gave us an N. This is our sample size, or you can think of it as the number of trials. Then what they did is they gave us an X value. So if they say exactly with an X, that's kind of your cue that that's your X value. So they've given us, and I'm going to rewrite this actually, an N and a P and an X. So hopefully if you hear NPX, you want to be thinking binom PDF. Okay. So this is something that we're going to plug into the calculator in this order. So a quick note on, let's see which, oh yeah, we were just on that page. So a quick note on that. So if we want the probability of exactly a certain number of successes in a certain number of trials, then we're using binom PDF. But if instead of wanting to know exactly a certain number of successes, if we instead want to know, like, up to a certain number of successes, okay, I did give an example here. So if we wanted to know 3 or fewer successes, then instead of using binom PDF, we would use binom CDF because it is cumulative. It is everything up to and including whichever one we're looking for. Okay. Now they do give you a formula if you were to do this by hand for Binom PDF, they're not expecting you to show this work or to do this by hand. They want you to know that there's a formula and know that you can use that formula, but they're not expecting you to do this by hand. They're expecting you to do this. They're expecting you to plug it into the calculator. Okay. So remember that these are um, um, binomial distributions, right? Distributions, distribution. So if you're like, well, where do I go in the calculator? How can I remember where to go? Well, you go to where it says distribution. So going back to the problem at hand, this is going to be Binom PDF. So we're going to go second. We're going to go vars because above vars is distribution, right? Second vars. And we want to go all the way either, this up a little bit, either we want to go all the way down to Binom PDF, or I can go second vars and I can go up. So I go up and it starts back down at the bottom again, and it's a fewer number of clicks. Or if you've been doing problem after problem after problem and you keep using the Binom PDF and you remember that it is alpha, that it is A, then when you're in second vars, you can just say, hey, I just give me A. So I don't know if you can see on my calculator, the light is kind of reflecting funny, but there's an A in yellow right above my math button. So in the same way that if I wanted to do inverse norm, I could just press the number 3. I wouldn't have to arrow down and hit enter on 3. I could just press the number 3. I'm going to select A for alpha by hitting alpha math because A is directly above my math button. So I'm going to hit alpha math and it puts me directly into the Binom PDF menu. Okay, now if you have a nice pretty calculator like mine, this fancy updated one, mine's nice and pretty and purple, then that's great. This is going to prompt you with what the heck you're supposed to be plugging in here. If you have an older calculator, it still works, you are still fine, but it might not prompt you with what you're supposed to put in here. All it's going to do is give you this and the parenthesis, and you have to know what you have to give it and in what order. So you have to know NPX and you have to know to put it in that order. Okay, so N is, let's go ahead and label these, the number of trials, right? P is your probability, and then X is your number of successes. I don't know if I spelled that right. Excuse me. So trials, what was our N? Our N was 14. Our probability was 0.63. And we wanted to know exactly 5. Oops, sorry, exactly 5. So if you have the older calculator, this is what it's going to display. It's just going to display Binom PDF right here, and you have to type in the 14, comma, 0.63, comma, 5. And then we hit enter, and it gives us our probability. Again, we need to make sure that we're rounding to the nearest thousandth. So 0.0258. Look to the number to the right. This is 5 or more, so that's why we're going up to 0.026. Okay. So if you want exactly a certain number of successes, you're going to be using Binom PDF. If they want more than just exactly a particular number, like if they want at least 3 or up to 3 or 3 or 4 or whatever, something other than that, then you're going to use a different process, potentially Binom CDF. But we'll get to that if one of those problems comes up, which I'm pretty sure it does. So, okay. Number 9, the probability that a tennis set will go to a tiebreaker is 14%. What is the probability that 2 of the 3 sets we'll go to a tiebreaker, round the answer to the nearest thousands. Okay, so again, let's start labeling things. So probability, you know what, let me write this a little bit down. 0.14. What is the probability that 2 of 3 sets? Okay, so they're wording it a little bit differently here, but they're saying that there's a total of 3 sets, that our n is 3. And they want to know what's the probability that exactly 2 of them will go to a tiebreaker. Okay, so you see how they've worded it a little bit differently there, but they're still giving us the same elements. They're still giving us the same pieces of information that we need. So again, we're going to go to second vars. And then we're going to go to, oh, I didn't write it over there, but we go to A, which is binom PDF. And we're going to be asked to give it an N, a P, and an X, where N is our trials, P is our probability, and X is the exact number of successes. When we're in binom PDF, X is the exact number of successes. Okay, so I'm going to go second vars. I'm going to go ahead and use that alpha math to go directly to binom PDF. And now I'm going to plug in my N, my P, and my X. And then they want us to round to the nearest thousandth. So again, that's the thousandths. We look to the number to the right. It is 5 or more. So this number goes up 1. Okay. All right. Okay. A survey asks, sorry, I know this one's small. I was trying to fit the whole thing on a page here. Okay, a survey asks 1,500 workers, has the economy forced you to reduce the amount of vacation you plan to take this year? 52% of those surveyed said, so that's something we're going to need to come back to. 52% of those surveyed said they are reducing the amount of vacation. 10 workers participating in the survey are randomly selected. The random variable represents the number of workers who are reducing the amount of vacation. Decide whether the experiment is a binomial experiment. If it is, identify a success, specify the values of N, P, and Q, and list the possible values of the random variable X. Okay, so the first thing it wants us to do is to say, is the experiment a binomial experiment? So we, just trying to see if I have that in the notes here. Yeah, so in order for something to be a binomial experiment, it has to meet certain criteria. So there has to be a fixed number of independent trials. Okay, so fixed meaning we know exactly how many there are going to be. And yeah, there are. We've selected specifically 10 workers. The trials are independent. So one person's answer doesn't affect another person's answer. Only 2 outcomes for each trial, either success or failure. Again, success doesn't necessarily mean a good thing. Failure doesn't necessarily mean a bad thing. So yeah, there's only 2 options. Either they are or they are not being forced to reduce the amount of vacation that they plan to take this year. The probability of a success is the same for each trial. So we're using the uh, the it, what's a good way to say this? The probability for each person is not different. And then the random variable X is the number of successful trials. Okay, so yeah, that works. So that's all of them. Second part, what is a success in this experiment? So selecting a worker who is reducing the amount of vacation. That's what they're being asked about. Okay, that's what the 52% said, that they are reducing the amount of vacation. So this is an example of one where what is happening is not necessarily a good thing. So the success is that they're reducing their vacation. Okay. All right, specify the value of n. Real quick, let's just go back and let's identify all these things ourselves rather than doing it kind of piecemeal like this. So we read through the problem. 52% of those surveyed say that they're doing this thing, right? So also kind of going back to like when we were talking about number 3, the probability of success is the same for each trial. That's the probability of success that we're going to be applying to however many workers that we're going to be looking at, the 10 workers. That's the probability that we're looking at. Said that they are reducing the amount of vacation. 10 workers are participating. That's our N in the survey. Okay, and then so it wants the value of N. Okay, so we found that. It wants the value of P. Okay, we found that. Then it wants the value of Q. Okay, well, we've done this before, right? Q is the complement of P, so we just have to subtract it from 1. Right? Whenever you have one of them, you can always find the other. So that's how they're getting 0.48. Okay, and then they say list the possible values of the random variable x. So remember, you can always make your table, right? So you have 10 workers. So maybe none of them are reducing their vacation time. Maybe one of them is reducing it. Maybe 2 of them, or 3 of them, or 4, 5, 6, 7, 8, 9, or maybe all 10 of them. So one common thing that I see is that people forget to include the 0. Don't forget to include the 0, right? So make a note there. Don't forget 0. Because it could be that none of them do the thing. So in this case, what's the thing? The thing is reducing the amount of vacation that they're taking. So it could be that none of them do that, or maybe all of them do that, or somewhere in between. Now, it's not actually asking us to find the corresponding probabilities, but if we wanted to, we could, right? Like if I wanted to find this one, I would do, oops, I would do binom PDF. My n is 10. My p is 0.52, and I want to know the probability of exactly 3 successes. So I could do that for every single one of these if I wanted to find all of those probabilities. But it's just asking for these. The list of 0 all the way up through your n, right? So 0, 1, 2, all the way up through whatever your sample size is. And our sample size here is 10, or the number of trials, right? N, sample size, number of trials. Okay. All right. Number 11, 59% of US adults think that civil rights for Black Americans have improved during their lifetime. You randomly select 8 US adults, find the probability that the number who think that civil rights for Black Americans have improved during their lifetime is exactly 3 and exactly 6. Okay, so again, we're going to start labeling things. 59% of US adults, that's our P. You randomly select 8 US adults, that's our N. So for A, they're saying find the probability of successes in this particular situation is exactly 3. So for A, our X is 3. So we're going to do binom PDF because it's exactly 3, N, comma, P, comma, X. Second vars, I like to do alpha A just to get there faster. 8.593. And then we round to 3 decimal places here. Okay, so for B, they're asking is exactly 6. So again, the X exactly. So we're going to do binom PDF of N, comma, P, comma, and now my X is 6 because they want exactly 6. Okay. Quick little thing in the calculator. We can definitely go back and do second vars and go back into the menu, or if you want, if you arrow up and highlight that binom PDF, if you hit enter, it will take that and copy it and paste it down at the bottom so that you can go back and tweak it and edit it without having to go back into the menu. So again, I arrowed up. Once I was on it, I hit enter, and that pasted it down at the bottom for me to adjust before hitting enter. So keep in mind that's something you can do if you want to save yourself even more clicks. But if that's too many things to remember, that's fine too. You can always go back into second vars and then arrow down or up or use the alpha to get to binom PDF. And again, it's PDF because this is the exact number of successes, the exact number of successes. Okay. Okay, number 12, find the area under the standard normal curve to the left of z is equal to 1.25. Okay, so let's talk about some things here. Let's talk about what this looks like. So if we have a z-score, and we're trying to find area, then we can use whoops, I wanted to start with the mean. We can just use a standard, well, they're telling us it's a standard normal curve. That means that our mean is 0 and our standard deviation is 1. Okay, so remember our mean for a standard normal curve, our mean is 0, and then we can go 1, 2, 3, how many of our standard deviations we want in each direction, and the standard deviation is 1. They're asking us for the area under the curve to the left of z equals 1.25. Remember, z is the number of standard deviations away from the mean. You are. So this is a positive number, which tells me I'm to the right of the mean. If this were a negative number, I would be to the left of the mean. So this is positive 1.25, so I'm 1 1/4 approximately to the right of the mean. Okay, so this is a z-score of 1.25, and they want the area under the curve to the left of that. So they want all of this. Okay, so there's 2 ways to do this. You can look it up in the back of the book. Right? You can find the chart that has your z-scores on the outside, and then in the body of the chart is the area. Okay, and you would find, the 1.2, and then you'd find the 0.05 here, and you'd see where they intersect, and that gives you the area. Okay, remember in the back of the book, if you're doing the chart, it always gives you the area to the left. Okay, I mean, we are looking for the area to the left, but sometimes we're looking for the area to the right. The chart will always give you the areas to the left. Or you can instead do the calculator. I shouldn't have written it there. It's fine. So when we want to fill this in. We're going to have several things that we're going to be putting in here, okay? So we're going to go second vars, and you're going to arrow down to normal CDF, okay? And again, if you have the newer, fancier calculator, it's going to prompt you. It's going to prompt you with 4 things: your lower bound, your upper bound, your mean, and your standard deviation. So again, if you just have a standard normal curve, your mean is 0, your standard deviation is 1. It's not always going to be a standard normal curve. Or if instead of using z-scores, you're using x values, then the corresponding x value to that z-score, then you would need to put in whatever your mean and your standard deviation are. If you don't have those x values, your mean is 0, your standard deviation is 1. We talked about that there. Okay, lower bound and upper bound. What are they talking about there? The lower boundary of the shaded region, the upper boundary of the shaded region. We're shaded from here to here. So we want to know the lower boundary and the upper boundary. Now keep in mind that this curve technically goes on forever and ever. I know that's a weird concept, but it does. Even though it goes on forever, the area under the curve, the whole thing adds up to 1. Okay, so those are kind of some basic points of interest that you want to make sure that you know. All right, so this lower bound, well, it's negative infinity, right? It goes on forever and ever. Okay, but I can't plug in negative infinity. Okay, so instead, what I'm going to do is I'm going to plug in something kind of close to it. I'm going to plug in -1 times 10 to the 99th. Okay, now I don't want to plug in -10 because that's not low enough. And I don't want to plug in -100 because that's not low enough. Even -10,000 is arguably not low enough. So something like -1 times 10 to the 99th. Now, in my calculator, it's already got -1e99. So remember, when you have that e, that means times 10 to the whatever. So it's already there. I don't need to plug it in. Now, maybe in a different problem, I might need to plug it in because maybe I need to have, either positive or negative of that. But in this one, it's already got it. Great. I don't need to plug it in. Okay, the upper boundary. So again, I'm dealing with z-scores here. I have z-scores, so I'm going to use a mean of 1 and a mean of 0 standard deviation of 1. And I'm going to give it the z-score, because that is my upper bound. My upper bound is right here, and the corresponding z-score of that is 1.25. My mean is 0. My standard deviation is 1. Okay, so upper bound is the upper boundary of my shaded region. Mean is 0. Standard deviation is 1. It's probably already going to have the 0 and the 1 in there. Okay. So again, if you have kind of an older calculator, this is what it's going to show you. It's going to show you just normal CDF with a parenthesis, and you have to type these in. Again, you have to know what order to put them in. You have to separate them with commas. Then you can hit enter. And then we want to make sure that we're rounding our answer to the correct number of decimals. So remember, what we're finding here, that number is the area under the curve of the shaded region. Right? So about 89% of the curve is shaded. Yeah, that looks about right. That sounds about right. Okay. Let's see, do they? No, hold on just one second. I think, do I have any of the? Yeah, I'm just gonna jump real quick to, I want to use, just because I want to show you real quick. I mean, I talked about it a little bit here, but I want to show you what it actually looks like. So if you're going to use the chart, so we're looking for, real quick reminder, we're looking for a z-score of 1.25. So there's both the negative section, right, z-scores that are negative numbers, and then there's the positive section. We're looking for a positive 1.25. So on the outside, I have 1.2, and then I need a 5 so that I get 1.25, right? So 0.05. So I'm going to say, okay, where do these overlap, right? or not overlap, but yeah, where does the row and the column meet? At 0.8944. So again, if you're using the chart, the z's are on the outside, the corresponding area to the left of that z-score is in here. Okay, so that's if we wanted to do it manually. Okay, so find the area under the standard normal curve to the right of z equals negative 1.25. Okay, so standard normal curve, it's a mirror, right? This half looks exactly the same as that half. I mean, I know I didn't draw it that way, but that's because I'm not a very good artist. If the area to the left of positive 1.25 is 0.8944, and I'm doing the area to the right of a z-score of negative 1.25, so the exact same number, but this one's positive and that one's negative. If we look at the shaded region, it looks the same as that, right? It's just flip-flopped because it is, right? You'll notice 0.8944, 0.8944, right? So if you've already done this problem, then you're like, oh, I already did that math. It's just on the other side, right? Am I looking at the bottom 89% or am I looking at the top 89%? Okay, so that's one way to do this problem. Another way to do this problem is in the calculator. So let's do it in the calculator. So again, this is normal CDF. I never leave myself enough room when I write this out. We have a lower bound, B-O-U-N-D, an upper bound, boundary, our mean, and our standard deviation. Okay. So in this case, our lower bound is a z-score of negative 1.25. Again, negative, make sure you've got the negative there. Okay, my upper bound. Well, my upper bound is infinity, but I can't type in infinity. So instead, I'm going to type in positive 1 times 10 to the 99th, because that's a really big number. And then again, if it's a standard normal curve, my mean is 0 and my standard deviation is 1. So we get to it by going second vars. We can either arrow down to normal CDF or we can just hit 2, excuse me. My lower bound is negative 1.25. My upper bound is my z-score of 1 times 10 to the 99th. Sorry, real quick, let me show you how I typed that in case you weren't aware. I did 1 times 10. This is the caret symbol, so to the 99th. And then if I hit enter, okay, well, it didn't do it here, but if I like exit out of this and go back, it'll probably say like 1E99. And then I've got my mean of 0, standard deviation of 1, copy and paste. And look at that, we're getting the same number, right? Again, if we're rounding to 4 decimals. And then the last way we can do this is by looking at the chart. Okay, so let me bring the chart back up here. Okay, so a few ways to do this. You can either flip your Z and say, well, I know that if I instead, so let's pretend like we didn't do the previous problem and we're doing this problem fresh. Okay, we can either look at this and say, well, I know that if I find the area to the left of a positive 1.25, it's going to be the same as the area to the right of a negative 1.25. And the reason you might want to do that is because in the back or on the table, the area that you're given is the area to the left. So that might save you some work. So we would go back to this, we would find a z-score of 1.25, and we would say Okay, positive 1.25. I have an area of 0.8944, and I know that if the area to the left of this positive z-score is that, then that means that the area to the right of the corresponding negative z-score is also that. Okay, so that's one way to use the table. Another way to use the table is to say, well, let me just start by seeing what the table tells me about negative 1.25. Okay, so we're going to go to the chart that has the negative z-scores. We're going to go to, again, negative 1.2 and then 0.5. These are both negative, so that we get negative 1.25. Okay, negative 1.25. Okay, and we get this right here. Okay, right, negative 1.25. And we say, okay, great, but what did that just give me? What is this area? That area, that 0.1056, that 0.1056 is this, because the chart always gives you the area to the left of the z-score. So if this area is 0.1056, how could I find what this area is? Well, the area under the whole curve is 1. So this section, the shaded section, plus the unshaded section is 1. They add up to 1. So all I would have to do is subtract that from 1, right? 1 minus 0.1056, and we get 0.8944. Okay. So again, you can, if you happen to, and you're not necessarily going to, but if you happen to be given the same type of problem back to back where they're just mirrors of each other, you can think of it that way. You can do the problem fresh in the calculator, which is probably what you're going to end up doing. Or you can certainly use the table. You can absolutely use the table. And when you go to use the table, you can do it two different ways. Either find the reflection, because it's easier to find the area to the left because that's what the table actually gives us, or use the actual z-score that you have and then take the area that it gives you and subtract it from 1 because that gives us the area that we actually want. Okay? All right, lots of options. Okay, number 14, find the area under the standard normal curve between z equals 1 and z equals 2. Okay, so again, standard normal curve between z is 1 and z is 2. So here's our mean, and then we have a z of 1 and a z of 2, and we only want the area in between. Okay, so again, several ways to think of this. Okay, if I have the area to the left of z equals 2, and from that I subtract the area to the left of z equals 1, my z's look funny, sorry, I'm going to get the area in between. Does that make sense? Let me do some, like, from here to here is this, right? From here to here is this. I mean, I would draw it directly on top of the pink, but then it would be hard to see. So if I take the pink and I subtract the blue, I get the in-between, right? So this is one way we can do this if you want to use the table, right? So if you're using the table, you go pull up your table. We want to find the area to the left of a z-score of 2. 2.00, 0.9772. Okay, and then we're going to subtract the area to the left of a z-score of 1. So I'm going to go back. Got a little bug flying around here. 1 is 0.8413. I should have finished this equation here. Equals, oh, ran out of room. Oh, that's terrible looking. That's not good enough. We're going to fix that. Oops. Sorry, 1 and 2, not 2 and 3. I was about to do 2 and 3. Okay. So let's plug that into our calculator. 0.9772 minus 0.8413, and we get 0.1359. Okay. Okay, so that's if we were going to do it by hand using the table. So remember, another option that you can absolutely do is the calculator, right? Let's do this in the calculator. So if we're going to do normal CDF, we have our lower bound, we have our upper bound, we have our mean, and we have our standard deviation. Okay, what's our lower bound going to be? The shaded area we're trying to get, the lower boundary of that is a z-score of 1. The upper bound of the shaded region is a z-score of 2. My mean is 0. My standard deviation is 1 because I'm doing z-scores, and this is a standard normal curve. Second vars, normal CDF, lower bound is 1, upper bound is 2, mean and standard deviation, and there you have it. Okay. So again, you always have the option to do these by looking it up in the chart, but more often than not, it's going to be faster to do it in the calculator. But it is important for you to understand what the chart gives you and understand that you can do it like this, right? Okay. Find the area under the standard normal curve between those two values. So again, same type of thing, right? Mine never look even. That's fine. Okay. So we have a negative z-score. So I know I'm going to be to the left of the mean. And then I have a positive z-score. So I know I'm going to be to the right of the mean. And I want the area in between that. So again, I could do, okay, I'm going to find the area to the left of that. And then from it, I can subtract the area to the left of that, and I'll be left with my shaded region. Or I can just normal CDF it. Lower bound, upper bound, mean, and standard deviation. You want to do it so many times that you can do it in your sleep, right? Make it muscle memory. Second vars, normal CDF. Lower bound is negative 1.5. Upper bound is 2.5. 0 and 1 for my mean and standard deviation. And there we have it. Again, if we round the way that, so you can see, like before you even do the problem, you can see that all of these numbers go to 4 decimal places. So you can say, okay, whatever answer I get, I need to make sure I go to 4 decimal places. Okay. Right, number 16. Find the probability of Z occurring in the indicated region. So what they've done is they have, they've given us the, like the graph of what they're doing. So instead of us having to create the graph, they've given us the graph. Okay. So they've given us our z-score. Okay. So again, we can use the chart, or we can use normal CDF. You know what? I'm not gonna write lower bound, upper bound, mean, and standard deviation. I've written it a bunch of times. Let's just plug in what we're going to use here. All right, the shaded region. What's the farthest over here? What's the lower boundary? Negative infinity. Well, I can't write negative infinity, so I'm going to write -1 times 10 to the 99th. That's my lower boundary. My upper boundary is the z-score that they gave me, 1.82. My mean and my standard deviation are 0 and 1 because this is a standard normal curve. They didn't say that, but it is. And also, if they haven't given it to you, you're assuming that it is. So again, second vars, normal CDF, -1 times 10 to the 99th. 1.82 is the z-score that they've given me there, and then 0 and 1. And that's how we're getting our 9656. But again, if you wanted to look it up in the chart, we're going to look up a z-score of 1.82. So not here because these are negative. So I go here, 1.82, that's 1.8 and 0.02. Right? That's how we do that. So 1.82, right? That's where those intersect. 9656. And what was our answer? 9656. Okay. I'm going to keep these off to the side because we're just going to keep referring back to them maybe. Okay. And then we got another. Same thing. Normal CDF. My lower bound is all the way over here, which is negative infinity, or we're going to write it as, since we can't write negative infinity, we're going to write a really, really low number, -1 times 10 to the 99th. My upper bound is this z-score that they've given me of -0.59 or 0.59. My mean is 0 and my standard deviation is 1, right? Mean, standard deviation. So again, remember we can do where we highlight the thing that we want it to recreate. So I've arrowed up to be highlighted on my normal CDF, and when I have hit enter, it copies and pastes that for me. And I can go back and I can adjust it. So I'm going to keep this -1 times 10 to the 99th, but instead of 1.82, I'm going to do -0.59. And then, oh, I messed up, my the numbers there. So I need to make sure that I put a comma, right? Because these get separated by a comma, 0, 1, and close parentheses. Okay. And that's how we're getting 2.776. Again, if that whole copy and paste thing is too complicated, do not even worry about it, right? Our goal here is not to make things more complicated by using the calculator. The goal is to make your life easier and faster with the calculator, right? They want you to know how to do it by hand, know that it exists by hand, and then they want you to learn how to use technology to do it faster. So if trying to use shortcuts on the calculator is difficult or confusing for you, don't even worry about it. Don't use it. Okay, find the probability of Z occurring in the indicated region. It's kind of hard to tell there, but it's shaded over here, right? Shaded to the right. So again, we can look this up on the chart. We just have to make sure that we say, okay, well, if I look up 1.75, it's actually going to tell me this over here. So I'm going to do 1 minus whatever it tells me on the chart. So what does it tell me on the chart? A z-score, remember z is the thing on the outside, of 1.75 is 9599. Because this 9599, that's this area to the left. So we're going to do 1 minus that. Okay, that's how we're getting the 0.0401. Right, so for some of you, that might feel faster than to say, okay, I gotta go second vars, I gotta arrow down, I gotta I gotta say, oh, no, that's not my lower. My lower boundary is 1.75. My upper boundary is infinity, but I can't type that in. So instead I'm going to type in 1 times 10 to the 99th. And then my mean and standard deviation are 0 and 1. And then if I round that appropriately, I'll get 0.0401. So this one, to me, doing it manually actually felt easier. Felt like it was fewer steps, fewer things I had to type in, less work, right? So you got to do it enough times that you can kind of figure out what's going to be fastest for you and your preference. Okay, find the probability of Z occurring in the indicated region, which is between these two values. Okay, so I think that for me, this is probably going to be faster on the calculator. So let's just do this on the calculator. So again, we're going to go second vars, normal CDF. My lower bound is my lower Z-score. My upper bound is my upper Z-score. And this is a standard normal curve, mean of 0, standard deviation of 1. And there we have it. Same thing here, right? 0 to 1.5. Again, if you want to do this in the chart, you would do like looking it up on the chart. Just want to show you something real quick here. So when Z is 0, when we are no standard deviations from the mean, that means we're at the mean. And the mean separates the bottom half from the top half. So the bottom 50% from the top 50%. So I don't even have to look at the chart to know that the area to the left of a Z-score of 0 is 0.5. So I don't even have to look that up. I would have to look this up if I'm using the chart. 1.5, 1.50, right? 0.9332. Sorry, could you guys see that? I didn't check to see if you could see what I was looking at there. Yeah, you could. Okay. So I can just plug that in. Minus 0.5. And there we go. Or let's say I forget that that's, by the definition of what a Z-score is, if the Z-score is 0, I'm at the mean, which means that it's just 0.5. If I forget that, I can say, oh, well, if I go to 0, it's 0.5, right? It'll just save you some work if you do that. Or again, we go in the calculator, our lower bound is 0, our upper bound is 1.5, and we get the same answer. Okay. Okay, so again, same thing. Well, generally same process. We can either say, I'm going to reflect this because this is asking for the shaded region to the right. Well, the table's not going to give me that. The table's going to give me the area to the left. So if I'm looking it up in the table, I can either reflect this and say, well, if I just go negative 1.36, the chart's going to give me the area to the left of that, which is exactly the same as the area to the right of that, right? These areas are the same. So I can go to my chart, negative 1.36, 0.0869, and there it is, 0.0869. Sorry, you guys can't see that, right? Negative 1.36, there it is, 0.0869. Or, right, so that's one option if I'm using the chart. Another option if I'm using the chart is to say, well, I'm going to do 1 minus what that Z-score gives me. Because the Z-score, if I look it up in the back, is going to give me the area to the left. So we look up a positive 1.36. positive 1.36. Right? Yep, 0.9131. So again, that 0.9131, that's the area to the left. Well, I don't want the area to the left. I want the area to the right. So I just have to do 1 minus 0.9131. And I get 0.0869. Again, same number. Or I can do it in the calculator. And I can say, what's my lower bound? It's a z-score of 1.36. What's my upper bound? It's infinity. Well, I can't do that, so I'm going to do 1 times 10 to the 99th. Mean of 0, standard deviation of 1. Excuse me. And you can see that we are getting the same number. So hopefully you guys are getting the idea of the different options that you have when you're doing these problems so that you can get a feel for what you feel most comfortable doing. Okay, so I'm just going to do this one in the calculator. Second vars, normal CDF, my lower bound, my upper bound, leave my mean and standard deviation as 0 and 1. And there it is. Again, if you wanted to do this looking them up in the back, you would do the area to the left of a z-score of 1.2 minus the area to the left of a z-score of negative 1.3. And that would give you the area in between. I'm just kind of running a little bit quicker through these because I want to make sure that we have enough time to do all the problems here. I know we're always running over on time, but we got to be done by 5. So. Okay, for the standard normal curve, find the z-score that corresponds to the 90th percentile. Okay, so when they say 90th percentile, that means that you are looking, let me just draw this. The 90th percentile is what separates the bottom 90 from the top 10. Okay, so you have to remember that that's what that means, not the other way around. I think sometimes people get confused and they try and put like the bigger number to the right or something, but whatever number that is, whether it's the 90th or the 5th or the 1st or the 99th, whatever that is, that's the left. That's the area to the left of whatever your thingy is, of whatever your z-score is or your x value. Okay, so we're doing this kind of backwards now, right? Because instead of having a z-score and finding the area, we're given the area and we're asked to find the z-score. Okay, so let's start by doing that on the table. Okay, so we say, okay, well, which table do I even start with? If my z-score, I'm sorry, if this is 0.9, that means my z-score is going to have to be pretty far over here because I'm saying that 90% of the area under the curve is to the left of it. So it's going to be over here. It's going to be a positive z-score. So I'm not going to look at my negative table. I'm going to look at my positive table. And what I'm going to do is, remember how we talked before about how the numbers on the outside are the z-scores, the numbers in the middle are the area. We're looking for an area, and once we find it, we're going to see what the corresponding z-scores are on the left and on the top. So we're looking for an area of 0.9. Now they go to 4 decimals here. So 0.900. So that's what we're looking for. Okay. So we're looking for an area of 0.900. Okay, so we don't have that exactly, but look at what we have here. So we have 0.8997, and you might say, oh, that's really close. And then you look over here and you might get confused. You might say, well, that's close too. Which one of these do I choose? So if they are exactly the same distance apart from the number we're looking for, then you go directly in between them. But these aren't. These are not the same distance apart from 0.90000. Now, a lot of people have trouble with the decimals. So one way you can think of it is, for just a second, forget about the decimals. Pretend it's not a decimal. Pretend this is 9,000. If I said, what's closer to 9,000? 8,997 or 9,015? It's going to be this one. This is only 3 away. This is 15 away. Does that make sense? This is only 3 away from 9,000. This is 15 away from 9,000. So this is closer. Okay, so since we don't have this exact number in the area section, we're going to find the thing that's closest to it, and we're going to look at the corresponding z-scores, which is 1.28. And there we have it. Okay. All right, now, what if we wanted to do that in the calculator? So if we wanted to do that in the calculator, what we're going to do is we're still going to go to, so first of all, I'm going to write this out, that if you're given the area and you need the z-score, then you're going to do the second bars, but you're going to go inverse norm, INV norm. Okay, so again, if you have kind of the nicer, fancier calculator, it's going to give you this option of, well, where is this area occurring? Is this the area to the left of whatever we have, or is it in the center, or is it in the right? You'll learn more about the center thing later, but anyway, this is the area to the left, is 0.9. Oh, I didn't, hold on just one second. That was number 3. I never finished writing that down. 3, inverse norm. Okay, so we have the area to the left is 0.9. Well, I'm not gonna fill that in there. And then again, we leave our 0 and our 1, and you want this, if you do have this calculator, you want it to say left because the area is occurring to the left of the value that we're asking it to find for us, right? We're not saying that the area is to the right of it, we're saying that the area is to the left of it. So make sure that left is highlighted, okay? And then we hit enter, and we have to go to 2 decimal places. So when we go to 2 decimal places, we get 1.28, okay? So you look at what they're asking for, you look at what you have, and you go from there. Because sometimes you're given a z and you find the area. Sometimes you are given the area and you find the z. Okay. Oh, and then it just had more of the tables for us to use. Okay. So this one says specifically to use the table to find the z-score that corresponds to what? To the 5th percentile. So remember, what does the 5th percentile mean? It means the bottom 5%. Whatever that percentile is, that's the area to the left of whatever value we're going to find. So if the area down here is 0.05, not that I need to find it, but if I wanted to, like if I wanted to label that, I could say the area over here is 0.95. We're not going to be using that number, but yeah, so the area to the left is 0.05. So again, they want us to use the table to find the z-score that corresponds to that area. We're going to be way over here to the left of the mean, which means that I'm dealing with a negative z-score. So I'm going to look on this chart for an area of 0.05. Okay, so that's going to be right here in the middle, 495 and 505 are both 5 away from 500, right? 1.65. Oh wait, I'm sorry. I'm getting ahead of myself. It's yeah, I'm sorry. I am getting ahead of myself, but it's these are both the same distance away from 0.05, which is what we're looking for, right? We're looking for that area. I was getting ahead of myself because I was talking about halfway between the 5 and the 4. Okay, so this is where we want to be. I would circle this and I would say what's over here to my left and what's up here. So I have a negative 1.6, and then I have 0.05 and 0.04 exactly halfway between those. You want to make sure that you don't accidentally say 0.055 because that's over here. Halfway between 0.04 and 0.05 is 0.045, right? 45 is halfway between 40 and 50. So that's how we're getting, those are both negative, 1.645. So that's how we get that if we're using the table. So if we're using the calculator, we're going to do our second var's inverse norm, because again, we've been given the area. We're trying to find the z-score that corresponds to that area. So the area to the left is 0.05, and there is our z-score. Now, something else that you could do is, if you want to be like, if you want to play around with this, you could say, okay, well, the area to the right is 0.95, right? Area to the right is 0.95, and I get the exact same number because it's the exact same value that separates the left 5% from the right 95%, the bottom 5 from the top 95. Okay? Right. Okay, the body temperatures of adults are normally distributed with a mean of 98.6 degrees Fahrenheit and a standard deviation of 0.72. What temperature represents the 95th percentile? Okay, so we're not just dealing with means and standard deviations of 0 and 1 now. We're getting into actual values representing actual real life situations. So let's draw this out. So they told me that I have a mean of 98.6. And I'm off to the side, I'm going to write that I have a standard deviation of 0.72. What temperature represents the 95th percentile? So remember, what does 95th percentile mean? It means I'm going to erase this so that you don't think we're separating that out. It separates the bottom, like this whole area here is 95%, and this area here is 5%. So this score right here is what separates the bottom 95% from the top 5%. Okay. Now, they didn't just want a z-score though. They wanted an actual temperature. So what we have to do is we have to start by finding the z-score. Right? We have to get the z-score, and then we can turn that into our x value, right? What is the x value here? Okay, so by the way, this is if we're doing it by hand. We're going to do this by hand, and then I'm going to show you how to do it in the calculator. Okay, so first thing is, what is this z-score? So we're going to look up in the chart the area. Did I get rid of those? I did. Just use these right here. We want the z-score that corresponds to an area of 0.95. So an area of 0.95, okay, is going to be directly in between these two values. So that's going to be 1.645. Okay, so that's my z-score, 1.645. Okay, now that I have a z-score, I need to turn that into an x value. So here's where your formulas come in that you have to have memorized. So you hopefully remember from uh, previous chapters this formula. Your z-score is your x minus your mean over your standard deviation. You can either plug your values into this and then isolate your x, or you can memorize that if you were to rearrange these to get x equals, that it would give you mean plus z-score times standard deviation. So you can either memorize this, or you can be good enough at your algebraic rules to just plug in here. We'll do it both ways just so that you can see. So I have a z-score. It's 1.645. I don't have an x value. Remember, your x value is like your real world number. Your z-score is how many standard deviations from the mean that real world value is. The real world value is the temperature. Your x is your temperature or your age or your IQ or whatever the particular situation is calling for. The z-score is how many standard deviations that value is from your mean, right? Always remember the relationship between those. Okay, so what is our mean? Our mean is 98.6. And what is our standard deviation? It's 0.72. Okay, so I need to solve this equation for x. So x is having multiple things done to it, subtraction and division. I need to get rid of this division first. To get rid of division, I do the opposite function, which is multiplication. Whatever I do to one side of the equation, I have to do the exact same thing to the other side. So multiplying and dividing by the same thing, they cancel each other out. On the left, I can multiply these together to get 1.1844 equals x minus 98.6. And then to get x completely by itself, I need to get rid of this subtraction, so I'm going to add. Adding and subtracting the same thing cancel, and I get just x. And so I'm going to put these two together, and I get 99.7844. So that is my x value. And they're just having us go to two decimal places. Okay. Or if instead of doing that algebra, if I memorize this formula, because this is just a rearranging of these terms, right? But if I plug into here, I say my mean is 98.6. My z-score is 1.645. And I'm going to go ahead and put that in parentheses because it's being multiplied by my standard deviation, which is 0.72. So remember our order of operations. I have multiplication happening, I have addition happening. I need to do this multiplication first. Or you can just plug it into your calculator all at once. I get the same thing, 98 or 99.7844. Okay, so that's if we were doing it by hand. So what would this look like if we were doing it in the calculator? So when we were doing normal CDF, remember back when we were doing that a little bit earlier, we were looking at our lower bounds, our upper bounds, our means and our standard deviations. Well, I don't know that bound, right? What I do know is I'm sorry, what I don't know, or I'm sorry, what I do know is the area. What I'm trying to say is that this is an inverse norm, just like the ones that we just did a minute ago, right? So we go to second vars, we go to inverse norm. And this is everything that we have. We have the area. The area to the left is 0.95. We have a mean, right? This is not just a standard normal curve. This is a specific situation. We have a mean, it's 98.6. We have a standard deviation, it's 0.72. And that area is to the left, right? Sorry, the reflection, you can't really see that. So we're doing inverse norm because we have the area and we're trying to find the corresponding either X value or Z score. If you have the area, I think I wrote that somewhere. So if you're given the area and you need the Z score, which by the way, once you have a Z score can lead to your X value, or instead of a Z score, you can do an X value if you also have a mean and a standard deviation, that's when we use the inverse norm, okay? So again, on your like your formula sheets here, right? We would have somewhere in there, we would want to say, I don't know where I have it in there, that if I'm given an area and I need a Z-score or an X value, I'm using inverse norm, okay? So then I paste that in and I'm getting my 99.78. So no matter which way you do it, you're getting the same thing. Okay. All right, use the standard normal table or technology to find the Z-score that corresponds to the cumulative area 0.2247. Okay, so what do they mean cumulative area of 0.2247? That means the area to the left. This is 0.2247. It's 22% approximately. So we know since 22% is less than 50%, we know we're to the left of the mean. So again, I'm given an area. I'm asked to find the corresponding Z-score. So that's inverse norm, right? Given an area, find a Z-score or an X value. That's inverse norm. Second vars, and then the third option is inverse norm. So the area to the left is 0.2247, but they didn't give me a mean or a standard deviation. So we're saying 0 and 1, right? You always got to remember that. The standard normal curve is 0, a mean of 0 and a standard deviation of 1. And then we paste, and we're getting, again, you round to 2 decimals, and we get negative 0.75. And again, as with everything in this class, you want to take a look at your answer and you want to say, hey, does my answer make sense in the context of the problem? If I had plugged that in and I had gotten a positive Z-score, I would have been confused. I would have said, wait a minute, that can't be right. I'm over here to the left of the mean. I need to be getting a negative Z-score, right? So just check yourself in case you run into anything like that. I've said before, I say I have fat fingers, right? Like I often accidentally type the wrong thing into the calculator. So I'm always checking to make sure my answer makes sense in case I did a typo. Okay, similar problem. Again, use the standard normal table or technology to find the Z-score that corresponds to the cumulative area of 0.7507. So what does that cumulative area mean? It means that this is 0.7507. To the left, they want us to find that value. If we're given an area and we need to find the Z-score or the X value, that is inverse norm. 7507. Again, if they haven't given that to us, it's 0 and 1. And if we go to 2 decimals, that's what we get. Use the standard normal table to find the Z-score that corresponds to the given percentile. If the area is not in the table, use the entry closest to the area, right? We've done that a few times here, right? Where we said, okay, it's not there, I find the closest one, or I have to find the one that's in between. Okay. Oh, and yeah, here they say if it's halfway in between, use the Z-score halfway between the Z-scores. or you can use technology. So remember this notation, P90, it's the 90th percentile. You might have heard those terms, like if you have kids, or maybe when you were a kid, when they say, oh, your kid's in the 70th percentile, that means that they're doing better than 70% of the other students. This is P90. That means the area to the left of this particular score, it separates the bottom 90 from the top 10. I don't need to worry about the fact that this is 10. I just need to worry about this 90. I'm given an area. I'm being asked to find a z-score or an x value. So that means I'm using inverse norm. The area to the left is 0.9. They haven't given me a mean or a standard deviation, so it's 0 and 1. And that's how we get our 1.28. So again, find the indicated z-score. It's giving us an area, and it's asking us to find the corresponding z-score. So again, we have the area, we're being asked for the z-score, we go to inverse norm. The area to the left is 0.1469, and that's how we get, again, if we round to 2 decimals, negative 1.05. Or again, if you wanted to do this in the table, you would look for in the body of the table an area of 0.1469, and you would find a corresponding negative 1.05. Guys probably couldn't see that, right? So you find 0.1469, and it gives you that same z-score. Okay. All right, we're almost done, guys. Okay, again, z-score, if we're doing this in the calculator, inverse norm, you can either, so if your calculator doesn't give you the option of left, center, and right, then that means it's doing left, okay? So if you have an older calculator, you need to give it this area. But if you have one of these calculators, you can just tell it, hey, the area I'm about to give you, that's actually the area to the right of what I want you to find. So 0.0951, mean of 0, standard deviation of 1, and that's the area on the right of the z-score I'm asking the calculator to find. And again, if we round to 2 decimal places, 1.31. Okay. All right, so we are in the final stretch here, okay? Just a couple more problems. So the lengths of a lumber machine cuts are normally distributed with a mean. So first of all, that's good to know. They're normally distributed, okay? They have a mean of 104 inches. They have a standard deviation of 0.3 inches. What's the probability that a randomly selected board cut by the machine has a length greater than 104.09? So normally distributed. Got a mean 104. We're looking at a length greater than 104.09. So that's going to be somewhere to the right, probably not very far to the right. Maybe, yeah, I didn't write that small enough, but this is an x value of 104.09, and we want greater than that. So we want shaded to the right, okay? So we were doing these types of problems earlier, right? Where we have this value, we want to find the area. Hang on just 1 second, guys. Thanks for your patience there. Yeah, it's just about 5 o'clock. We are going to keep going until we're done here, but we are almost done, I promise. Okay, so yeah, so this is we want the probability that the x value is greater than that. So we want the area to the right of that. So do you remember what we do when we have the x's or the z's and we want to find the area? Hopefully you remember. If not, that's okay. That's why we're doing these reviews. This is where we're doing the normal CDF, right? Lower bound, comma, upper bound, the mean, and the standard deviation. And unlike some of the problems we were doing before, we actually have numbers besides 0 and 1 for our mean and our standard deviation, which means that if we put these numbers in here, we can give lower and upper bounds that are x values rather than z-scores, right? So we're going to go second vars. We're going to go normal CDF. Our lower bound is the x value of 104.09, right? Is that the number that they gave? Yeah, 104.09. My upper bound of my shaded region is infinity. I can't write infinity, so I'm going to do 1 times 10 to the 99th. My mean, again, it's not 0, it's 104. I actually have a number for it. And my standard deviation is 0.3. I didn't need to write the 0. I could have just written 0.3. I don't know why I did that. Sorry, you guys can't see that because of the reflection. All right. And there it is. That is the area, right? If you're given bounds and means and standard deviations, or if you're just given bounds and you can assume that these are 0 and 1, and you're asked to find area, that's when you use normal CDF. Okay, so that was A. All right, what is it asking us for in B? A sample of 45 boards is randomly selected. Okay, so now we're getting into some different things here, right? Now we have an N. We've got a sample inside of this population. A sample of 45 boards is randomly selected. What is the probability that their mean length is greater than 104.09? So this is not just that we're not just dealing with these, okay? We're dealing with a sample within this population, okay? So what we can do here is we can remember, sorry, I'm trying to get my formula pulled up here, some of our formulas, okay? So we're going to be doing this by hand because we are using a sample here, okay? The z-score is going to be our value. Actually, let me write this out in words first. Let's do the words, then we'll do the symbols. The value minus the mean over the standard error. So this is a slightly different formula because I'm looking at a sample here. Okay, that's why we're using this formula that's slightly different. Okay, so how is this slightly different? This is our sample value, okay, minus the mean over the standard error of the mean. Okay, so now do you guys remember the formula for the standard error of the mean? It's going to be the population standard deviation over the square root of your sample size. Okay, so this is one of the formulas that you want to have memorized. This is very similar to your other z-score, except because we're dealing with a sample size, this is the standard error of the mean, right? Okay, so we're going to find this first so that we can plug it in here. Because this is actually that, right? So we could do it all at once, or you could find this first and then plug it in. Okay, so let's find that. Let's find the standard error of the mean. We're going to take our we're going to take our population standard deviation of 0.3, and we're going to divide it by the square root of the sample size. I didn't write that down. And oh, I did. I wrote it right here. N is 45. Okay. So we have 0.3, you guys can't see that, divided by the square root of the sample size. Okay, so we get that number. That is our denominator. Okay. Okay, our value is our 104.09, right? It's our value. When you're doing these samples, you can say that the sample, the mean of the samples is the population mean. So we can say 104. And down here, we have this value that we just got. Now, I'm not going to round, okay? I'm going to use that exact number. So I'm going to say 104.09 minus 104 divided by the thing I just got. Okay. So that gives me, and that thing I got was, if I were to round it, it would be 0.045. So that gives me a z-score of 2.012. Okay. So kind of same sort of principle here, where I have a z-score there, and I want the probability that it's greater than that. So if I have the z-score and I want the area, I'm going to do normal CDF. Okay. My lower bound is my z-score. I mean, I am rounding here, but my mean is the 0 and the 1, because this is a z-score. Okay, so I think this might be the first one that we've done where we're kind of jumping back and forth like this. Okay, if you're giving them a z-score, you need to be giving them the 0 and the 1. If you're giving them an x value, then you're giving them whatever the actual mean and the actual standard deviation are. Okay. And that's how we're getting our 0.0221. Okay, so this is a great problem for several reasons. So it's got a lot of information packed into just one problem, right? It's asking you to remember a lot of things, and it's forcing you to really make sure that you understand the difference between these two things that it's asked, right? Because you might look at this and you might say, well, what's really the difference here, right? We're both saying the same thing, right? We're both saying greater than 104.09. The difference is, in this one, we took a sample, a specific number, and we're talking about the sample statistics of this sample. Within the sample, what's the probability that it's greater than 104.09? Versus, hey, we've got this population, and what's the probability of what's happening with it? Okay? That's why this is such a great problem. But there's a lot going on here, right? That's the other great thing about it, right? So you're like, okay, I got to know this formula. I got to know this formula. I got to remember that I'm allowed to use that. Essentially, we're saying that the mean of the samples, we can use the population mean, right? So like all these little things all tied up into one problem. Okay. All right, and this is the last problem. So the weights of ice cream cartons are normally distributed, yay, with a mean weight of 9 ounces and a standard deviation of 0.3 ounces. What is the probability that a randomly selected carton has a weight greater than 9.11 ounces? So again, that's an X value of 9.11. We want the area to the right of that. Okay, so this is going to be the same process as the last one, right? So we can go normal CDF. We can say my lower bound is 9.11. My upper bound is 1 times 10 to the 99th. Because I gave it an X value, I need to give it the mean and the standard deviation. Right? If I'm giving it a Z-score, I need to give it 0 and 1. If I'm giving it an X value, I need to give it the mean and the standard deviation that's specific to this problem. Okay, so when we plug that in to our normal CDF, okay, we're getting the area to the right of that, right? Because we gave it the bound, the lower bound, the upper bound. We're getting that probability, okay? But then, right, so that's all population information. Now we're gonna dive deeper. We're gonna say, okay, well now I'm just looking at a sample of 36 of these things. Well, now what's the probability that their mean weight is greater than 9.11? Okay. So again, we're gonna go ahead and find the standard error of the mean. Okay, we've got our 0.3 over, there's a bug flying around here, over the square root of our sample size. What was our sample size? 36. Hold that thought, guys. I gotta go move the motion sensor. So yeah, so we've got 0.3 divided by the square root of 36, which is 6. So we get 0.05. So that's nice. We don't have to do rounding there. And the whole reason we needed that is because we're going to plug it into our formula that uses the standard error of the mean to find the corresponding Z-score. Okay. Okay, so we have 2.2. Okay, so we have the Z-score. Oops, I don't know why I drew 2 lines there, of 2.2. We want to find the area to the right of that. So we're going to normal CDF that. Our lower bound, it's up a little bit, is our Z-score of 2.2. Our upper bound is infinity. I can't write that, so I'm writing 1 times 10 to the 99th. Because I gave it a Z-score, I need to use a mean of 0 and a standard deviation of 1. And there we have it. So you'll notice, just like the last one, these numbers are different, right? When we're talking about the population, this is the probability that it's going to be greater than 9.11. When we're talking about a sample of 36, the probability that in that sample that the mean weights are going to be greater than 9.11 is much less. Okay. All right, and that is it. That is the final problem. Okay, so again, I'll be sending this out to you guys along with this recording, and just let me know if you have any questions. Feel free to come into any of the ASCs to get some help. And just make sure that you've got those calculator menus written down and memorized so that you can get to them easily. Okay. All right.
Yes. Thank you so
Well,
much for
good
your
luck
help.
to you.
Question.
Oh, hold on. Let me
Will
turn the
you
volume
send?
up.
Sorry. Okay. Sorry.
Okay. Okay. Say that again.
I was saying that thank you for your help and your assistance. And I was just wondering if are you gonna send this sheet right here as well?
Sorry. Can you hear me?
Yes, I can hear you.
Okay.
Can
Sorry.
you
I
hear
think my
me?
microphone got muted. I don't know how that happened. Yeah, I'm gonna send this out to you.
Perfect. Thank you so much.
Yeah, absolutely. Absolutely. Okay. You know what? I might send this out to you now. Um, because it's going to take a while for the recording to become available. I probably won't be able to send the recording out until tomorrow morning. So I'll send the recording out to you tomorrow morning, but I'll send this sheet out to you now. Okay.
Yes, perfect.
Okay. All right. Well, have a good night and good luck. Okay.
Thank you so much.
All right. You're welcome. Bye.
Have a good one. Bye.